This is our review for final exam review. So first we're going to find any intercepts and test for symmetry with respect to both axes and the origin. So in order to find the x-intercept, we need to let y equal 0 and solve for x. So here we have our equation, y equals negative 2x plus 1. So we let y equal 0. And so we get negative 2x plus 1, solve for x. So we're going to subtract 1 on both sides. And we get negative 1 equals negative 2x. Divide by negative 2 on both sides. So we end up with negative 1 divided by negative 2 is equal to x. And so if we simplify, we get x equals a half. So when x is a half and y is 0, then that is our x-intercept. And so now we're going to look for the y-intercept. To look for the y-intercept, we're going to let x equal 0 and solve for y. So if I substitute my x with 0, then I end up with negative 2 times 0, which is 0, plus 1. So we get y equals 1. So my y-intercept is 0, 1. The next step is to look for symmetry. So if we look at the graph, we can see that there's no symmetry. But let's do this algebraically. So when we want to find if the graph has x-axis symmetry, then we're going to be changing our y to a negative. So we take our equation, and anywhere we see a y, we're going to replace it with a negative y, and then we're going to solve for y. So here I have replaced my y with negative. So in order to solve for y, I just divide by negative 1 on both sides. And so I get y is equal to positive 2x minus 1. And so here, if we compare our final answer, y equals 2x minus 1, with our original equation, we can see that they're not the same. So we say that we have no x-axis symmetry. To check for y-axis symmetry, we're going to do something similar, but this time we're going to replace our x with a negative x. So anywhere that you see an x, we're going to replace with a negative x. So we end up with negative 2 times negative x, which is going to give us a positive 2x plus 1. So again, if we check the answer y equals 2x plus 1 and compare it to the original equation, we can see that they're not the same. So we say that there's no y-axis symmetry. The last one is to check for the origin symmetry, which means that we're going to change the x and the y, make them both negative. So I'm going to replace my y with a negative y, and I'm going to replace my x with a negative x and simplify it. So if I divide by negative 1, then I end up with y equals negative 2x minus 1. And when we compare it to our original equation, they're not the same. So we say that there's no origin symmetry. Okay, another question that we have is write the standard form of the equation of a circle with the given characteristics. So here they tell us that the center is negative 4, 2, and the radius is 2. So in order to do this problem, we should write down the standard form of a circle, which is x minus h squared plus y minus k squared equals 2r squared. They give us the center, and so the first number here, negative 4, is our h, and the y, or the second number here, is our k. So our radius, we can write it as r equals 2. We're going to substitute those values into the equation. So we end up with x minus negative 4 squared plus y minus 2 squared equals 2 squared. So if we simplify inside the parentheses, we get x plus 4 squared plus y minus 2 squared equals 4. And so that would be our answer. Write equations of the lines through the given point, parallel to and perpendicular to the given line. So here they give me this line. So the first step is to find the slope of that line. And so in order to find the slope of the given equation, we have 8x minus 2y equals 3. So the first thing that we're going to do is solve for y. So I'm going to subtract 8x. So here, I'm going to subtract this 8x. So I end up with negative 2y equals 3 minus 8x. Next, we're going to divide by negative 2. And so we end up with 3 halves, negative 3 halves minus 8x divided by -2. Simplify, so we end up with y equals -3/2 plus 8 divided by 2 is going to be our 4x. And we have a negative and negative, so it becomes positive 4x. Once we have our equation in slope-intercept form, then we would like to find out what the slope is. So in this case, our slope is going to be 4. So the equation has a slope of 4. And so for the parallel lines, we know that parallel lines have the same slope. So we are going to use the same slope of 4 and the point that they give us, 8, 1. And then we're going to use the point slope form of the equation. So we're going to plug in these numbers. So we have y minus 1 is equal to the slope, which is 4, x minus 8. We're going to distribute that 4 into the parentheses. And so we end up with y minus 1 equals 4x minus 32. We're going to add 1 on both sides of the equation so that we can simplify. And we end up with y equals 4x minus 32 plus 1, which will be y equals 4x minus 31. So this is our parallel equation. For perpendicular, we use the negative reciprocal of our slope. Since our slope was 4, the negative reciprocal is going to be -1/4. Then we use the point slope form to substitute in our values. So we're going to multiply -1/4 into the parentheses, and we end up with y minus 1 equals -1/4 x minus -8 times -1/4. If we simplify and add 1 on both sides, then we end up with y minus 1 is equal to -1/4 x. -8 times -1/4 is 2. And we add the 1 to this side, so we get 3. So our perpendicular equation is y equals -1/4 x plus 3. The next type of question we have is find the following. So they give us an equation, f of x equals 9x plus 1, and g of x equals x squared minus 4. We want to solve for, we want to add the two equations, f plus g of x. So the first step is to write down how this is defined. So f plus g of x is the same as f of x plus g of x. So f of x is the red equation up here, which is 9x plus 1, and g of x is the blue equation, x squared minus 4. So if we gather our like terms, we end up with x squared plus 9x minus 3. For f minus g of x, we rewrite it as well. So we end up with f of x minus g of x. Substitute the equations, 9x plus 1 minus x squared minus 4. We're going to distribute this negative into the parentheses, so we get -x squared, and negative is a +4. Gather your like terms, so we end up with -x squared plus 9x plus 5. For multiplication, we end up with f of x times g of x. So we have 9x plus 1 and x squared minus 4, so we're going to multiply 9x times x squared and 9x times 4, which is 9x cubed and -36x. And then we multiply 1 times x squared and 1 times -4. Gather your like terms, so we end up with 9x cubed plus x squared minus 36x minus 4. For division, we have f of x divided by g of x. So we have 9x plus 1 divided by x squared minus 4. We cannot simplify further, so this would be our answer. So we're going to go ahead and look at the domain of the quotient here. And so the domain, we cannot have a 0 in the denominator. So that means that we're going to have a restriction. So to find those restrictions, we set our denominator, x squared minus 4 equal to 0. Solve for x, so x squared equals to 4. So we end up with x plus 2 and minus 2. So these numbers that we just solved here cannot be part of our domain. So we need to not include them. So the domain is all real numbers except for 2 and -2. So in interval notation, we would end up with -infinity to -2, union -2 to 2, union 2 to infinity. Does the function have an inverse function? So the function that we're looking at here is the blue line. And so in order to determine if this function has an inverse is 1, we can use the vertical line test to make sure that it is a function, which it is. But we use a horizontal line test, which is illustrated here with the red line, to check to see if we have an inverse. If the horizontal line crosses your graph in only one place, then the function will have an inverse. And then just note that if a graph is not a function, then it cannot have an inverse. Okay, so this one is a function, therefore, and it passes the horizontal line test, therefore it does have an inverse. So what do we want to find the inverse? So here, in order to find the inverse, in this example, we have a root function, and it does pass the vertical and horizontal line tests. And so the inverse, first, we're going to replace our f of x with y. So here we get y equals square root of x minus 8. And then we're going to switch our x and y. So anywhere you see a y, we're going to replace it with x. And anywhere you see an x, you're going to replace it with y. Then we're going to solve for y. So in order to solve for y, we're going to square both sides. And so we end up with x squared equals the square root of y minus 8 squared. The square root and the 2 are going to become a 1, so we get y minus 8 is equal to x squared. We're going to add an 8, so we end up with y equals x squared plus 8. And so then we change the y back to the symbol for inverse, which is f inverse of x is equal to x squared plus 8. So the next question is sketch the graph of the function by applying the leading coefficient test, find the real zeros, and plot sufficient solution points, and then draw the graph. So let's focus on the first part, applying the leading coefficient test. So as a review, if you look at these four functions, the first one is f of x equals x squared. And so something to highlight here is that you have an even exponent and a positive coefficient. So if that happens, then your graph is always going to rise to the right and rise to the left. If you have a negative leading coefficient with an even exponent, then your graph is always going to fall right and it's going to fall left. The third one says if you have an odd exponent with a positive leading coefficient, then your graph is going to rise to the right and fall to the left. And then last one, if you have an odd power or leading an odd degree, then your leading coefficient is negative, then the graph is going to rise to the left and fall to the right. So if we look at our example, we have a negative leading coefficient with an even degree. So that's going to be like the second graph. So the graph will fall right and will fall left. Find the zeros of the polynomial. So we have many different ways to solve, to find the zeros. And so we can use the methods from chapter 2. And so here I'm going to go ahead and factor. You could use the quadratic formula as well. So if we factor, we end up with 0 is equal to x squared minus 12x plus 32. So the factors are 0 equals x minus 8 and x minus 4. Set each factor equal to 0. So the first one we get x equals 8, and the second one we get x equals 4. So those would be our zeros. So we have our zeros, we have the end behavior. We also want to find the y-intercept, which is to let x equal 0. So anywhere you see an x, we replace it with the 0, and that gives us y equals negative 32. The other thing we can look for is the vertex, and the vertex is negative b divided by 2a, and f of negative b divided by 2a. So in our example, b is 12, and a is negative 1. So 12 divided by negative 2 is 6. And to find the y-coordinate, we plug it back into the equation. So we end up with negative 6 squared plus 12 times 6 minus 32, which is equal to 4. So we have all these points. So then we can just put them together and sketch the graph. Find the rational zeros of the polynomial function. So we can use the rational zero test, which tell us to look at the factors of the constant term. So the constant in this case is 9, and the factors of 9 are 1, 3, and 9. Then the leading coefficient factors are 1, and so then you want to divide those together, and we use the plus and minus because we can have different combinations and still get that negative 9. So here we look at 1 divided by 1 is a 1, 3 divided by 1 is 3, and 9 divided by 1 is 9, with the both plus and minus. And so to enter into WebAssign, we write down the smallest numbers followed by the largest numbers. So once you have possible zeros, then we can use these to help us find the zeros. So if I want to find the zeros, the second step is to pick 1. So I'm going to choose 1 here. And if I do synthetic division, I bring down the 1 and then multiply 1 times 1 is 1. 1 plus 1 is 2. Multiply 1 times 2, which is 2. Add it to the negative 9, which is negative 7. Multiply 1 times negative 7 is negative 7 plus a negative 9, negative 16. Since we didn't get a 0, then that means that 1 is not a 0. So we check another one. Let's check negative 1. Negative 1 times 1 is negative 1, plus 1 is 0. 0 times negative 1 is 0. Negative 9 plus 0 is negative 9, times the negative 1 is positive 9. So we end up with 0. So that's a good thing because that tells me that x equals negative 1 is a 0. But most importantly, we can take the quotient and find the other zeros. So here, my quotient is x squared minus 9. Since our degree was a 3, then we start with 1 less here. So now we can take our quotient, set it equal to 0, and solve for x. So x is going to be equal to plus or minus the square root of 9, which is 3. So now that we have all this information, we have our zeros and everything, we can graph the polynomial. So first we plot the zeros, which were 3, negative 1, and negative 3. Then we apply the end behavior. So this is going to rise to the right and fall to the left. And we can see that because we have an odd degree with a positive leading coefficient. Then we need to plot additional points. And so here I chose negative 2, positive 2, and 1. So when we choose negative 2 and plug it in for all the x's, we end up with a 5. When I plug in a 2, I end up with a negative 6. And when I plug in a 1, we end up with negative 16. So if we plot those points, then we can see our graph is going to look something like this. Use a given 0 to find all the zeros of the function. So here, since 4 plus 2i is a 0, then the conjugate is also going to be a 0. So 4 minus 2i is also a 0. The degree is 3. That means we have 3 zeros. So we're missing 1 0. So that's what we're going to look for. So I'm going to use synthetic division. So we have 1, negative 12, 52, and negative 80. Bring down the 1. 1 times 4 plus 2i is 4 plus 2i. So if I add these, I add negative 12 plus 4 is negative 8 plus 2i. Then we're going to multiply 4 plus 2i times negative 8 plus 2i, and that gives me negative 32 plus 8i minus 16i plus 4i squared. Gather your like terms. So 8i plus negative 16i is 8i. And let me just go back. 4i squared, remember that I squared is the same as negative 1 times 4 is going to be a negative 4. So negative 32 minus 4 is negative 36 minus 8i plus the 52. So then we add 52 and 36. So we end up with 16 minus 8i, which we're going to multiply times 4 plus 2i. So that gives me 64 minus 32i plus 32i minus 16i squared. So the 32i and the negative 32i become 0. I squared is a negative 1 times negative 16. So if we simplify, then we end up with 64 plus 16, which is 80, minus 80 is 0. Okay, so that tells me that 4 plus 2i is a 0. So I do get my quotient. I get x squared plus negative 8 plus 2ix plus 16 minus 8i. So what we do is we use synthetic division again, but this time we use our conjugate 4 minus 2i, which is your second 0. So we bring down the 1 and multiply times 4 minus 2i. Gather your like terms, and you'll see here that the 2i and negative 2i cancel, leaving us with negative 4. Multiply, so that gives me negative 16 plus 8i, which is 0. So my quotient is x minus 4, and we're going to take that quotient and set it equal to 0, so x is equal to 4. So our zeros were 4 plus 2i, 4 minus 2i, and 4. Okay, consider the following. So we have a rational function, and we want to state the domain, identify the x-intercepts, the vertical and horizontal asymptotes, and plot additional points. So let's look at the domain first. Since we have a fraction, that means that there's some restrictions. So we're going to take the denominator and set it equal to 0. So if I solve for x, we get negative 3. So negative 3 cannot be part of our domain. So our domain is all real numbers except for negative 3, which is the last one here. The x-intercept, we let y equal 0 and solve for x. So in order to solve for x, I'm going to multiply by x plus 3 on both sides. So we end up with x plus 3 times 0 is 0. X plus 3 times 1 over x plus 3 is 1. So 0 does not equal to 1. So that means that there's no x-intercept. So our y-intercept, so for the y-intercept, we let x equal to 0. And anywhere you see an x, we replace it with 0. So in this case, we get 0 plus 3, which is 3. And if we simplify, we end up with 1/3. So my y-intercept is 0 and 1/3. Find the vertical and horizontal asymptotes. So remember that the vertical asymptote, you want to factor the numerator and denominator completely and cancel any like terms. Then you want to set the denominator equal to 0 and solve for the variable. And if you cancel any factors in step 1, those will have, that just means that your graph is going to have a hole. So here, your numerator and denominator are both factored already. So we set our denominator equal to 0. So in this case, they're already factored. Set the denominator equal to 0 and solve for x. So x minus 3 is a vertical asymptote, which if we were to graph it is a vertical line at x equals negative 3, but we use a dotted line, a dashed line. Horizontal asymptote, there's 3 situations: when the numerator is less than the degree of the denominator, when they're equal, or when they're greater. If step 3, if the degree of the numerator is 1 more than the degree of the denominator, then there will be a slant asymptote. So here the degree of the numerator is 0 and the degree of the denominator is 1. So that means that the degree of the numerator is less than the degree of the denominator. So if that happens, then we say that your horizontal asymptote is going to be the x-axis, which is represented with the blue line here. Okay, so we have all this information. So to graph it, we can plot additional points. So here's my vertical asymptote and my y-intercept. The additional points I'm going to pick are f equals negative 2. If I plug that in, I get a 1, and f of 2 is equal to 1/5. And then I can do a couple more. Some on the left side of the vertical asymptote, negative 4 gives me a negative 1, and negative 5 gives me a negative 1/2. So if I plot those points, then my graph is going to be equal to this one on the right side. So in WebAssign, it's multiple choice. So if we look at our graphs here, then we see that our graphs, and we pick the one that we think is going to be or is closer to what we drew on our paper. Okay, so the second one here, the vertical asymptote is in the wrong place, and the third one is in the wrong place. So it's between the first one and the last one. But then we can see that the graphs are incorrect. So my answer is the first one. Okay, let's use properties of logarithms. So here it says to expand and write as a sum or a difference. So if you notice here, x squared minus 9 is being divided by 4. So we can apply the quotient rule, which means that we can separate as log 5 square root of x squared minus 9 minus log 5 of 4. Then we can take the square root and write it as an exponent. So the square root can be written as a half, power of a half. And then we can use the power rule, which means that we can take our exponent here to the front. So we're going to have 1/2 log of x squared minus 9 minus log 5 of 4. And then we can actually factor x squared minus 9. And x squared minus 9 is x minus 3, x plus 3. And then since these are being multiplied, we can separate with the product rule, which means that we can write it as addition. And then we apply the half to both of those. So my final answer is 1/2 log 5 x minus 3 plus 1/2 log x plus 3 minus log 5 4. Condense means to end up with one log. So if you look at the first one, we're going to go ahead and change the numbers that are in the front to logs. So this 6 and this 7 will become exponents. So we get log y6 plus log z7. Then we're going to combine from left to right. And so notice that these two here are being subtracted. So we can use the quotient rule and put them as division. So we end up with log x divided by y6. And now we're adding to log z7. So we can use the product rule, which means that since they're being added, then we put them together using the product rule as multiplication. So we multiply x divided by y6 times z to the 7th. So that becomes x times z to the 7th divided by y6. Solve the logarithmic equation algebraically. So here we have natural log of x minus natural log of x plus 6 equals 7. So in order to solve, it would be good to combine these two. Since they're being subtracted, we can combine them with the quotient property, which means that we can combine them by dividing. So we end up with x divided by x plus 6 is equal to 7. Then we can change this natural log to an exponential form. So natural log, remember, is the same as log base e divided by x plus 6 is equal to 7. So if we change it, our base is e, and then the log is equal to the exponent. So since this log is equal to 7, then 7 would be our exponent. So to simplify here, we would multiply by x plus 6 on both sides. And so when we do that, then the x plus 6 cancels here. And we're going to multiply this, distribute the e to the 7th. So we get e to the 7th x plus e to the 7th 6 is equal to x. We want to put all the x's together on one side. So I'm going to subtract the x. And then I'm going to subtract this number here and bring it to this side. So now notice that these two have an x in common. So we can factor out an x. And we get x is x times e7 minus 1 divide by e to the 7 minus 1 on both sides. So we end up with x equals negative e7 times 6 divided by e7 minus 1. And so my answer is approximately negative 6.005. You always want to check your solution to make sure that this is a solution. And to do that, we take our answer, plug it in for each x. So if I plug in my number, this one, and for this x, I get natural log of negative 6.005. Since this number is negative, then there's no solution. The next one, I'm going to go ahead and combine these two on this side. So I end up with natural log of x plus 9 is equal to natural log of x minus 6 times x plus 6. So now notice that this side has the same log as this one, the same base. So we can use the 1-to-1 property, which tells us that we can set x plus 9 equal to x minus 6 divided by x plus 6. So we're going to solve for x. So I multiply x plus 6 on both sides. And when I do that, then this cancels. And I end up with x plus 9 times x plus 6 equals x minus 6. We're going to simplify. So we get x squared plus 6x plus 9x plus 54 is equal to x minus 6. So we're still going to simplify here. And we end up with x squared plus 15x plus 54 is equal to x minus 6. Bring everything to the other side. So I take my x, bring it to this side, and my 6, bring it to this side. So we end up with x squared plus 14x plus 60 once we have simplified. So at that point, we can factor or use the quadratic formula. So I'm going to go ahead and use the... So once we plug in our numbers, we can see that we end up with negative 14 plus or minus square root of negative 44. Since we have a negative in here, then we say that there's no solution. Here we're going to combine these two logs together. So we end up with log 9 divided by x divided by x minus 8. So we're going to change that to exponential form. So the 9, the log is equal to the exponent. So in this case, the log is equal to a half. So a half is your exponent. We multiply by x minus 8. Well, we can evaluate 9 raised to the power of a half is actually 3. So then we can go ahead and continue. So the square root of 9 is plus or minus 3. Then we're going to solve for x, braided as a positive 3 and a negative 3. So if we simplify, we're going to be multiplying by x minus 8 on both sides. That cancels. So we get 3x minus 8 equals x. And solve for x, we get x equals 12. And then on the right side, we do the same, and we get x equals 6. So we have two possible answers, but we must check our solutions. So if x equals 12, we plug it in. So we get log 9 12, that's okay. Log 9 12 minus 8 gives me a log 4, and that's okay since they're both positive. So that means that x equals 12 is a solution. Let's try 6. So we get log 6 minus log 6 minus 8. Well, that becomes a negative 2. And so that's going to make it no real solution or no solution. And so these are just some examples of what you'll see on the final exam. And then, of course, you'll see some questions that deal with matrices. And those will be next here on the review.
So for letter A, we only have one number, so that means that there's only one row and one column. It's going to be a 1-by-1 matrix. So then for letter B, we have one row and we have 4 columns. And so the order there is going to be a 1-by-4 matrix. And then letter C is made up of 2 rows and 2 columns, so that's going to be a 2-by-2. And then the last one is made up of 3 rows and 2 columns. This one is a 3-by-2. Let's write the augmented matrix first. Okay, so we're going to have our variables on the left side and then our constants on the right. And notice here we're going to have x, y, z, and w. So some are missing. If a variable is missing, then we just replace it with 0. So we have a number 1 here. For the first one, I'm going to look at the first row first. So we have a 1 for the x, we have a 3 for the y, and then there's no z, so that's why I'm going to put a 0 here. And then the y is -1, so here's my -1, and my constant is a 9. So we go to the next row. I don't have an x, so therefore I put a 0. Then my y is a -1, z is 4, and then w is 2. So then we have our constant -2. And then we go to the next row. So then we have our x is 1. There's no y, so we use a 0. And then 5 is a -5. And then 6 would be -6 for w. And then our constant is 0. So the last row would be 2, 4, -3, 0, and then our constant 4. So we can see here we have 4 rows and 5 columns. So write the system of a linear equation represented by the augmented matrix. And so here we have the 6. So whenever you have your systems like this, the first numbers are representing the x and the second numbers are representing the y. So here our first numbers are x, this is our y, and then these are our constants. So we're going to have, the 6 would be for x, so we write 6x. The 5 would be for y, so we write 5y. And then our constant is 2. And then the second equation is the second row, so we would have a 3x, a -9y, and then we have the 0. Okay, so now here, just another example. So the first number with the 1 represents x, and if notice you have a 0 for y, so y is going to be 0, and then you have your 4 as your constant. So here what we have is that x is equal to 4 because there's no y, and then the second equation there's no x, so the only thing we have is y is equal to 3. So we have our matrix, it's a -3, 4, and so on, and we have our first step is to go ahead and make sure that it's an augmented matrix, which it is, because they started with that matrix instead of a system. And our first thing that we want to do is make sure that we have a 1 in the diagonal. So we want to have a 1 in this diagonal. So we have a -3. So in order to make this -3 a 1, I'm going to multiply it by -1/3. So I'm going to have -1/3 times row 1, and whatever answer I get, I'm going to place back in row 1. Okay, so we have -1/3 times -3 is going to be +1. And then 1/3 times 4 is going to be -4/3. And -1/3 times 22 is going to be -22/3. So our next step is to make this 4, we want it to be a 1. So in order to make it a 1, I'm going to multiply by 1/4. Okay, so I'm going to multiply the second row by 1/4. And so that's what is being illustrated there in the pink. So this is going to be 1/4 times row 2. Whatever we get, we're going to place it back in row 2. Okay, so the first row, you don't want to change that, so I just write it out. And then I'm ready to do my multiplication. So I'm going to multiply 1/4 times 0, and that gives me a 0. And then 1/4 times 4 gives me a 1, and 1/4 times 16 gives me a 4. Okay, so we're a step closer to our goal. Now we want to change this -4/3 to be a 0. Okay, so the best way to do that is, again, you want to use the 1 that's right below it, the diagonal, and then just multiply the 1 by the opposite of whatever is up here. So since this is a -4/3, then we can multiply it by a +4/3. And then we're going to add them together because if they're opposites of each other, then it makes it a 0. Okay, so I'm going to illustrate that with the following there. So let's see, where did we go? So 1/4, we already did the multiplication. Okay. So we're going to multiply 4/3 times the second row. So that's illustrated with this right here. Then we're going to add it to row 1, and then we're going to put the answer in row 1. So here's going to be the work. Notice I wrote my second row because I don't want to change my second row. And so I'm going to take my 4/3 times the 0, and that's going to give me 0 plus 1, and I'm going to place my 1 here. And then 4/3 times 1 for my next one, plus the negative 4/3, and that's going to give me a 0. So 4/3 times the 1, and then we're adding it to the negative 4/3, and so that becomes 0. And then the third one is going to be 4/3 times 4, and then add it to the negative 22/3. So 4 times 4 is 16, so we get 16/3 minus 22/3. Subtract 16 minus 20 is negative 6. Divided by 3 is equal to negative 2, so that's going to be our last number here. So we have our goal, so now we can get our solutions. So the first one represents x, and the second one represents y. So x is equal to negative 2, and y is equal to 4. So I have two matrices here, A and B. And the first one says to multiply 3 times A. And so what we're going to do is take the number 3, and we're going to multiply each entry by the number 3. So we're going to multiply 3 times 2, 3 times this 2, 3 times this 4, and so on. 3 times this one, 3 times this one, and 3 times everything. Okay. And so once we do that, then our solution is going to be, I guess I had the 3 there. So multiply 3 by everything, and we end up with 6, 6, 12, negative 9, 0, negative 3, 6, 3, and 6. Okay, so that's going to be our answer. And then for the second one, negative b. Well, negative b is the same as saying we're multiplying by negative 1. And so we're going to multiply negative 1 to everything in the matrix. And so we end up with negative 2, 0, 0, negative 1, positive 4, negative 3, positive 1, negative 3, and negative 2. Any questions on those two? Okay, the last one, we have 3a minus b. So first, since we have subtraction here, you want to make sure that we have the same order, because in order to add or subtract, you have to have the same order. Okay, so for matrix A, our order is 3 by 3. And for matrix B, our order is 3 by 3. So we're okay. So since the orders are the same, we can multiply. We already figured out what 3a is, right? This was 3a. So I'm just going to write it over here. And then we already know what negative b is. So let me just write them over here. Okay, so this is your 3a. And then we have our b. So this is 3a, and this was negative b. So we can just add them now. So to add, you're going to take the first number, 6, plus negative 2. And that's going to give you a negative 8. Oh, I'm sorry, negative 4. And then you're going to take the next one, and you're going to keep adding all the numbers. So the next one is 6 plus 0 is 6. And then we're going to take 12 plus 0,
and then that's going to be 12, and then negative 9 plus negative 1 gives me a negative 10. 0 plus 4 gives me a 4. Negative 3 plus negative 3 is negative 6. 6 plus 1 is 7. 3 plus negative 3 is 0. And 6 plus negative 2 is 4. So that's what it means by adding corresponding entries. Okay, so again, the only way to be able to add or subtract is if the orders are the same. Okay, so another problem that you might see is solve for x and y. And all that they give you is the two matrices there. And so since they tell you that this matrix is equal to this one, then what that means is that each entry should be the same. Okay, so if I have an x in the first position, let me just get the marker. So if the x is here in the first position, and in the second matrix we have, let me see. So we have a negative 3. So the x has to be a negative 3 in order for them to be equal. And then we have the negative 4 and the negative 4, so that's okay. And then we have the 6 and the 6, so that's okay. And then we have 21, so that's going to tell me that y has to be 21. So my solution would be x is negative 3 and y is equal to 21. So if we look at the next one, we have 18 and 18, 5 and 5, and then we have x and 2x plus 5. So in order to solve that, we can set the x is equal to the 2x plus 5, and then we can solve for x. Okay, so, and then the same for the 16, it should be equal to 5y minus 4, and then we can solve each of the equations. So for the first one here, if I subtract 2x on both sides, then I get negative x is equal to 5. Divide by negative 1, so we get x equals negative 5. And then for the second equation, I'm going to add the 4 on both sides, so I get 20 is equal to 5y. Divide by 5 on both sides, so we get y is equal to 4. So here we have solve for x in the equation. So they give you the two matrices, and we want to solve for x. So we can take the equation 4b equals negative 2x minus 2a, and we can just treat it as an equation for now. So I'm gonna solve for x. So I'm gonna subtract the 4b to the left side or the right side, and I'm gonna take the 2x to the left side. So I end up with 2x is equal to negative 2a minus 4b, and then we're gonna solve for x. So if I divide by 2, I get negative a, and then 4 divided by 2 is negative 2. And so now I have this equation, and so I can use my matrices, check the order to make sure that the order is correct. 2 by 3 for both, so that's good. So I have a negative 1 times a and a negative 2 times b. So we're going to multiply that, and that gives us those two matrices. Okay, so after you distribute the negative 1 in here and the negative 2 in here, then we get this matrix and this matrix. So we can add the corresponding entries. So 2 plus 0, negative 1 plus negative 4, negative 1 plus 4, and so on. And so our answer is going to be 2, negative 5, 3, 1 plus negative 6 is negative 5, 0 plus 0 is 0, and negative 4 plus negative 6 is negative 10. Okay, so the first one is 1 by 2, 1 row, 2 columns. And the second one is 2 rows and 1 column. In order for you to be able to multiply, you have to look at this number and this number. So the number of columns of the first matrix, the number of rows of the second matrix. If they are the same, so these are the same, then what that means is that you can multiply. So you're going to get some answer. Okay, so you'll have your answer here. And the outside numbers, this one and this one, that tells you how big your matrix is going to be here. So in this example, you're only going to have one number to put in there. Okay. And I think we'll be able to work them out here in a second. If we reverse some, then this one here is 2 rows, 1 column. This is 1 by 2. Can we multiply them? We're going to look at the inside numbers here. They are the same. So we say yes, you can multiply. So now your result, the size of the result is going to be these outside numbers. So this would be a 2 by 2. So that means you're going to have a number here, a number here, a number here, and a number here. Okay, so let's go ahead and try it. Okay, so those are the same as I mentioned earlier, 1 by 1. Okay, so the way we're going to do it is we're going to take the first row. Let me highlight it here. We're going to take this row and we're going to multiply it times this column. So 4 times 1 is 4 times 1. And then we're going to add the 1 times the 2. So if we add them, we get 6. And so that's your one number here. So let's go to the next one. So it's going to be 1 times 4 is 1 4. And then 1 times 1 is going to be just 1 times 1. And then we'll reduce right now. And then you're going to have 2 times 4 and 2 times 1. And so if we multiply them out, then we get 1 times 4 is 4. 1 times 1 is 1. 2 times 4 is 8. And 2 times 1 is 2. Okay, so if it helps you to think about how big the matrix is going to be, and then write it out, then that might be helpful in making sure that you're multiplying correctly. Okay, so let's look at this one. Find a squared. So a squared just means multiply a times a. So here's my two matrices. I need to check if I can multiply this. So I'm going to check the order. So I have a 2 by 2. So the inside numbers, they are the same. So notice here the red ones are the same. So that means that I can multiply. And the green numbers are going to be the size of my matrix. So I'm going to have a 2 by 2. So that means I'm going to need a number here. I'm going to need a number here. I'm going to need a number here. And I'm going to need a number here. Okay, so let's go on. So first, we're going to use the first row. And I underlined it here. So I'm going to multiply 3 times 3 plus 1 times negative 1. So all of that together is going to be your first entry. And then the second entry is going to be 3 times 1 and 1 times 2. So that's your second entry. So I'm already done with my first row because I don't have no more columns. So I go on to my second row, which I have underlined here. So negative 1 times 3, and then 2 times negative 1. That's my third entry. And then negative 1 times 1 and 2 times 2. So if I simplify, I get 3 times 3 is 9. 1 times negative 1 is negative 1. If I add 9 plus negative 1, then I get the 8. And 3 plus 2 is going to give me my 5. Negative 3 plus negative 2 is my negative 5. And negative 1 plus 4 would be 3. Okay. The third method is going to be using this formula. So here, my solution, I went ahead and labeled these A, B, C, and D.
So you can see the formula right next to it. So we're going to multiply a times d. So a is 1 and d is -3 minus b. B is 4 and c is -1. Then we're switching a and d. So a and d is now switched. So here's my d. This is my d. So I'm going to switch it and put it up here. And then my my a was the 1. And so now notice that we went ahead and switched the a with the d. Okay, so here's my a and here's. So now for the next part, if we have a +4, then notice I wrote a -4. And then I had a -1, so I switched the sign. So I have a +1. Okay, so now we're going to do this algebra here. So 1 times -3 is -3, and -4 times -1 is +4. We're going to go ahead and add -3 and -4. So that gives me a 1. And 1 divided by 1 is just 1. And then 1 times each of these numbers is going to be themselves. So if you had a number 2, you would have to multiply it times each element. And so this is going to be our inverse. So notice that you got the inverse for all 3 methods was the same. Okay. So it says use any method. So I'm going to go ahead and use the formula. Okay. So is there any questions before we continue? Okay, so let's use the formula. So I write down the formula, and then we're going to go ahead and substitute the numbers. So here we have a is 3. So here's my a. And then d is 2. So I multiply those, 3 times 2. And then b is -1 and c is -2. So I'm going to multiply those here. I'm going to switch a and d. So I'm going to have a 2 and a 3. And then for b and c, notice that you had a -1 and a -2. So we change the signs to +1 and +2. If we simplify, we get 3 times 2 is 6, minus -1 times -2 is a +2. 6 minus 2 is a 4. So we end up with 1/4 times the matrix 2, 1, 2, 3. We're going to multiply by 1/4 into the parentheses or into the matrices. So 2 times 1/4 is 2/4. 1 times a fourth is a fourth. 2 times a fourth is 2/4. And 3 times a fourth is 3/4. Reduce your fractions, so 2/4 is the same as a half. And then we have the 1/4, the half, and the 3/4. So that would be our inverse. Able to solve a system. And the way we're going to solve a system is using this formula here. Okay. We're going to take the inverse times b, and that's going to give us our answer for x and y, or in sometimes c. So I'll tell you what the b and the x and all that mean here in a second. So it says use the inverse matrix to solve the system of linear equations. So we have a system here, and they tell us that this matrix is already your inverse. Okay. So this here is already A, or it's already the inverse, so I'm just going to call it A inverse. Okay, so A is 1, 3, -3, and 8. B is made up of your constants. So B is always going to be your constants. Okay, so these are my constants, and that's matrix B. And then you're going to need a matrix X. X is made up of your variables. And since we only have 2, they are X and Y. So whenever you do this, you're going to need to find A inverse first. Okay. But this problem already gives it to us. They tell us what the inverse is. So we don't have to do the work because they already give it to us. Here is our inverse. Let me go ahead and circle it again. So remember this guy here. That's our inverse. Okay, so to solve the system, we're going to write the inverse. So I wrote the inverse here. And then we're going to write our constants, which is 4 and 12. And then we're going to multiply the matrices together. So to multiply, remember we take the row. So we take this row times this column. So negative 8 times 4 is negative 32. And then 3 times 12 is 36. So negative 32 plus 36 gives us that 4. And then we go with the second row. Negative 3 times 4 is negative 12. 1 times 12 is 12, so we get 0. So from here, we can say that x is equal to 4 and y is equal to 0. Okay, so that is one way that we can solve this system. So the first thing you want to do is write down your matrices that you have. So in this case, my A is made up of all my coefficients. So that's the 1 in front of the x, the negative 5, the 5, and the negative 24. And then B is my constants. And then x is going to be my variables. Okay. So the first step is we need to know what A inverse is. So I'm choosing to use the formula. So I have 1 divided by A, which is 1, times D, which is negative 24, minus B, which is negative 5, times C, which is 5. I'm going to switch my A and the D, and I'm going to change the signs for B and C. Okay, so we simplify. We get negative 24 minus negative 25. Simplify some more. So we get 1 divided by 1. And so our inverse is going to be 24, negative 24, 5, negative 5, and 1. So this is our inverse. Okay, so it seems like we finished the work already. But remember, we're not trying to find the inverse. We did find it because we need it. But our answer is going to be once we multiply. So we take our inverse times the B. So we're going to multiply negative 24 times 27 and 5 times 128. And so that's going to be negative 24 times 27 plus 5 times 128 and negative 5 times 27 and 1 times 128. And so we get these big numbers, right? But when we subtract, simplify, we get that x is equal to negative 8 and y is equal to negative 7. Okay. So last one here, use the inverse matrix to solve the system. So they already gave you the inverse. So all you need is your constants, which are 0, 6, and 3. So we're going to multiply it, right? So here's my inverse times the constants. So we multiply this row times this column. So we have 1 times 0 is 0, 1 times 6 is 6, and negative 1 times 3 is negative 3. And so 6 plus negative 3 gives me this 3. Then we go to the second row. Negative 3 times 0 is 0. 2 times 6 is 12. And negative 1 times 3 is negative 3. So if we add negative 3 and 12, we get 9. And then the last one, 3 times 0 is 0. Negative 3 times 6 is negative 18 plus 6. So we end up with negative 12. So my solution, x is equal to 3, y is equal to 9, and z is equal to negative 12. Okay. Okay, so if we look at letter A, you're going to multiply 2 times 2 and then subtract negative 3 times 1. And so we get 2 times 2 is 4. And then negative 1 times negative 3 is positive 3. So we end up with 7 as our determinant. And then for letter, the next one, letter B, we're going to multiply 2 times 2 and 4 times 1. So we end up with 2 times 2 minus 4. And 2 times 2 is 4. Minus 4 is going to be 0. So my determinant is 0. And then letter C, we're going to have 0 times 4 minus 2 times 3 halves. 0 times 4 is 0. And 2 times 3 halves is 3. So we end up with 0 minus 3 equals negative 3.